Oh, okay. So today we're going to be going over volcanoes. Here's kind of what we're going to be discussing in our presentation here. What is a volcano? How are volcanoes formed? Some kinds of volcanoes, the 3 stages of volcano, and then of course we will address some famous volcanic eruptions. Okay, so throughout this presentation there are going to be some words that are going to be highlighted or underlined and italicized. You all are going to have a list of these words, and as we go through and we address each of these words and their descriptions or definitions, write down the information that is associated with each word, and that will be turned in at the end of the lesson about volcanoes. Okay, so first, what is a volcano? A volcano is a mountain that opens downward into a pool of molten rock below. So, molten rock means liquid rock, so it's a mountain that has an opening with liquid rock all below it. When pressure from within the earth builds up within this mountain, it will force the liquid rock up and eruptions will occur. Volcanoes are commonly cone-shaped and made up of layers of ash and lava. Okay, so inside a volcano, here's our little schematic. Here's all the magma chamber, the liquid rock that is all below the crust of the earth, which is right here. Here's the main vent that's going to go up through the volcano. This is where all of the magma will be forced up from the very pressure, and then it will explode and erupt. As you can see, you've got some of the lava flow after the eruption. With an eruption, you not only get lava, but you're also going to get ash and soot coming out of the volcano, kind of like when you burn a fire, and this is all going to be released into the atmosphere. So you can kind of think about how, with volcanic eruptions, you're not only going to get destruction from the lava, but you're going to also get environmental destruction and havoc on the environment from the ash and from the soot that's going to be released into the air. You can also see here some other vents. Some volcanoes have other vents that are going to go to the surface as well, not just the primary one. Alright, here's a fun fact about volcanoes. The name volcano originally comes from the Roman god of fire, who is Vulcan. How do volcanoes form? Okay, there are 3 steps to how volcanoes form. The first is magma from deep within the earth starts to rise to the crust, as we said. The magma rises up because it is hot, and as we know with kind of the same material, anything that is hotter than when it's cold is going to be less dense, it's going to be less heavy. So when it's heavier, it's going to sink to the bottom, and when it's lighter and less dense, it's going to rise upwards and go to the surface. The magma is going to pool in what is called a magma chamber, or a weak portion of the rock, or kind of a dug out portion of the rock that's going to be on the Earth's surface. When there's enough pressure exerted on the magma within this rock, it's going to be forced upwards and outwards, and because it's going to have such great pressure and the rock is going to be relatively weak, it's going to be able to break through. Going to break through the rock and force itself outward, which results in an eruption of lava. So the eruption is just all of the inside magma and then the lava being forced out of the earth through this volcano. What are some of the differences between lava and magma? Well, the lava and magma are both going to be liquid forms of rock. However, lava is liquid rock that's outside of the volcano, so the lava is after the eruption, and magma is liquid rock that's inside of the volcano. So when the liquid rock is inside of the earth, it's called magma, and when it's outside of the earth, it's called lava. Here's another fun fact. Volcanoes can be found on the ocean floor, even under ice caps. So even though the ice is cold, you can still have underwater volcanoes because the volcanoes are fueled from what's inside of the earth. And what's inside of the earth is always going to be very, 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 very hot. So while you can have cold on top of the earth, under the top of the water, under the ice, down below, deep within the earth's crust, it's still going to be very, very hot with lots of pressure, and you can still have volcanoes. What causes volcanoes? Well, and to sum it up, plate tectonics are what causes volcanoes. As you can kind of see from the pictures, especially on the previous one, the surface of the earth is composed of a whole bunch of plates that all kind of fit together like a jigsaw puzzle. And this is because the plates, quote unquote, on top of the earth are all composed of rock that is composed and made up of material and elements and minerals that are all significantly lighter and less dense than the material that's underneath. So the rock that we stand on, the earth, is significantly composed of less and less dense things than what is in the core of the earth and what is under the earth. This allows the plates to float on top of the earth, on top of all the liquid within the plates. And because, as we've known and we've learned before, there are convection currents that occur deep within the earth and underneath the surface within the liquid layer of the earth, the rising and the moving of the convection currents there, these plates are going to move, and they're going to move around, and they're going to collide with one another. And when these plates collide with one another, we can get subduction zones. And subduction zones are when the plates hit each other, and instead of bouncing apart or scraping on the top of the surface with each other, one of the plates is going to be forced underneath the other one. Like right here, see, this plate is hitting this one and it's going underneath. When that plate is forced underneath the other one, it's going to go deep into the earth, and as we know, deep underneath the earth, it is very hot, and that rock is going to melt, and it's going to become magma, which will then rise and then forms your volcano. Here is a diagram or schematic of, here's the subduction zone being forced under, and the magma from the melting rock is going up. Here's kind of, you can get in the idea of how this would be a subduction zone or a convection current here. There'd be rotation and movement. Here's another fun fact. The islands of Hawaii are composed of volcanoes. Now, they're not active volcanoes, as we can tell since people live there. However, these volcanoes they're still volcanoes, and they're not quite extinct. There are three types of volcanoes. The cinder cone, as we see here in this picture. Circular or oval cones made up of small fragments of lava from one vent that's been blown up, cooled, and then all fallen around. So it's one big eruption, and just all of the ash and all of the soot and all of the lava solidifying right there around that volcano. Another kind is the composite volcano, which is over here. These are steep-sided, and they're composed of many, many, many layers. Like so, the original one, the cinder cone, was one solid chunk. This, as you can tell, kind of right here, has many layers of volcanic rock mixed with the lava. And then there's shield volcanoes, which are more sloping, more shaped like a bowl, and you can see there's still lots of layers, kind of like the composite, but it's sloped more. So there's more, the flow of lava is going to be different than with the other ones because the lava has been able to get out farther. So maybe we can think that maybe the lava is maybe flowing faster since the lava has been able to expand outwards more and create more of a sloping kind of volcano. There are three stages in the life of a volcano. The first one is you have active volcanoes. This is one that erupts regularly. We still have active volcanoes around. Then you've got dormant volcanoes like Hawaii. They're not erupted for many years, but they still have some activity going on. And then you have extinct volcanoes, and those are volcanoes that are no longer active at all. The magma is all solidified. There is nothing going on within that volcano. Here is a schematic of all the various, you can see where all the volcanoes of the world are, where they're kind of focused in various places along the plate boundaries. The Ring of Fire is a spot where there are a significant amount of volcanoes in the Pacific Ocean. Over 75% of Earth's active and dormant volcanoes are here in this Ring of Fire. So we can kind of think that might be a reason why it's kind of called Ring of Fire there. Here's a fun fact: volcanic eruptions can send ash over 17 miles into the air. There's some deadly volcanic eruptions, as you can see that the Tamboro resulted in over 90,000 deaths from that one eruption. That's quite a lot. And as some recent eruptions that we've had in the United States, there was Mount Helen in 1980, which many of us I'm sure have heard about. There's Krakatoa in Indonesia in 1883, which is reported as the loudest sound ever recorded in history. And as we said, how we can think about with maybe the ash and how the soot could affect the environment, the reduced global temperatures for 5 years. And some of that is probably, a result from the ash and the soot being forced into the atmosphere and can prevent, the rays from the sun from breaking down and warming of the earth. There's also Mount Pelee in Martinique in 1902, and Mount Fujiyama in Japan in 1708 was the last eruption, and it's been dormant since then. But the last eruption lasted for 3 weeks. That's 3 weeks of lava flow. And keep in mind, too, that the lava doesn't always have to be very fast and very violent. You can have slow lava flow, but where it takes a long time to cool. So that would be why it probably would have lasted about 3 weeks. So here we're nearing the end here. So everyone, what is one thing that you learned about volcanoes through this presentation? I want you to write it down, and then we can discuss it in class when we go over it all, along with the list of words that you should have all been writing down definitions or descriptions with as well.